Today I want to discuss with you the clever and mind-bending tricks about pointers in C++ that make your code more flexible, elegant, and just plain fun to write. We'll cover function pointers, pointers to members, arrays of function pointers, and void pointers for callbacks. You'll see code examples for each topic with step-by-step explanation, and I bet you find this video helpful. Now, let's get started. First trick we call the strategy pattern without virtual keyword. For those who don't know what the strategy pattern is, the strategy pattern is a behavioral design pattern that lets you define a family of interchangeable algorithms, encapsulate each one, and make them swappable at runtime. Let's say we want to sort some data in different order. Instead of using if statement, we can apply a strategy pattern like you see it on your screen right now. Here we pass the strategy as a template parameter or a function object, resolving everything at compile time with zero virtual call overhead. Without the pattern, you'd write conditional logic everywhere. Now that we have figured it out, we can get to work. First up, the classic function pointers. They let you treat functions like data. You can pass them around, store them, and call them later. Think of them as the C way of implementing callbacks or the strategy pattern without needing a class hierarchy. Here, operation member points to any function with signature of the function that takes two integers as an arguments and returns integer value. Based on user input, we point it to a specific function declared in a namespace and call it as if it were a normal function. This avoids a long switch statements. Every time we need to perform an operation, the decision is made once, the execution is a single line, and it looks much more readable. The second trick we call array of function pointers. Again, instead of using a switch statement, we can build an array of function pointers and index it directly. This turns the mapping into one-liner, and it's super easy to extend in a long term of development. Here we have zero branching code. The operations array holds the function addresses, and getting an element gives us the right function instantly. This pattern is good for implementing state machines, command dispatchers, or even simple interpreters. You can also make the array as a constant expression if the functions are known at compile time, turning runtime decisions into table lookups. The third trick leads from the second instance. Using object-oriented power in C++, we can make these familiar functions part of the class members. You can reach it by adding pointer to a member function logic like this. The syntax is a bit hairy, but here's the breakdown. In this line, you can see a pointer to a constant member function of our calculator that takes two integers and returns another one. To call it, we use this combination of these symbols on an object. This is incredibly useful when you want to store callbacks that operate on a specific class, like custom event handlers or plugin interfaces. Combined with a map, you get a full dynamic dispatch system without virtual functions. Another trick will help us to serialize data with pointers to member variables. So the fourth trick is a property access. A pointer to a data member stores the offset of that member within the class. You can use it to read or write that field on any instance. This signature is a pointer to any data member of template type in template class. The function named printField can access any field you pass, without knowing its name at compile time. Imagine you're building a serialization system. You could loop over an array of member pointers and automatically read or write all fields. That's some next-level generic programming. And the last but not least, the fifth trick, the C-style callbacks with context. Before std function and lambdas, we had to pass user data to callbacks using pointer to a void type. This trick still appears in many C APIs and low-level systems, so it might be helpful for you one day. If you don't understand what I mean, I'm going to show you how to pass user data through a void pointer. You can take a look at this code. Okay, here's the explanation. The for each function doesn't know what the callbacks needs. We pass any context through void pointer, and the callback casts it back.
It's type unsafe but incredibly flexible. You'll find this pattern everywhere in libraries like SQLite, OpenGL, or ptrace, etc. And when you combine it with function pointers, you have a complete callback system. Okay, that's it for today's pointer tricks. If this information was helpful, you can try them in your next project. The array of function pointers and the member pointers can really clean up your code. I hope you enjoyed this video. Let me know in the comments which trick surprised you the most. Thanks for watching, and I'll see you in the next one.